Hey class, here we are, chapter 10. There are two new distributions we're going to look at, the chi-square distribution and the F distribution. So we've had the normal distribution, the T distribution. Here's two more. They work in similar ways. There's a table, there's StatCrunch, but they're just used for some different types of hypothesis testing. So for the chi-square distribution here are the types of things that you would use it for. The one we'll focus on is that goodness of fit test. That's really the highlight of 10.1. Okay, so you can read through. Here's some information about that chi-square distribution. Some things to point out. It's a skewed distribution, so you can see it's kind of like a skewed right distribution. And all of these values on the x-axis are positive, so you'll never have a negative chi-square score, right? So that's kind of cool. DF is involved, so the distribution does change depending on the sample size or the calculated degrees of freedom. The first thing you'll have to do is learn to use the chi-square table to find critical values. And here's the directions for that. So refer to this area right here if you ever have to find critical values. Most of the time, I think actually all the time, because we're just focused on goodness of fit, we'll be doing right-tailed tests unless you have some sort of just general find critical values using chi-square. Okay, so for these problems, we're just going to assume that df is n-1. Okay. That's our assumption unless we know it's different depending on the type of hypothesis test. Okay. So let's try it out. Here we have a right-tailed test with n10 and alpha 0.05. So you're going to pull up your chi-square table. Now, where to find that is in your tables packet, which you can find in the modules. It's the same location as the normal and the T. It's just the third one in that tables packet, table 6. So I'll pull it up on my desktop. It's a pretty easy table to use. It's one page, so table 6. Notice it's that, here's that T, here's the normal. It's that same packet. It's just that third one that you've probably seen and like, what do we use that for? We're using it now. Okay, so for this one, for a right-tailed test, it says in that bullet point, use the value of the corresponding df and alpha. All right, so that one, all we're doing is, okay, if n is 10, df is 9, and alpha is 0.05. So I'm seeing on that table a 16.919. That would be my chi-square critical value. So a chi-square sub 0. Okay. Now, if it's a left-tailed test, so if you're looking at the notes, number 2, and 14 alpha 0.1. For left-tailed tests, you've got to do 1 minus alpha, all right? So I'm actually going to do 1 minus 0.1 or 0.9, and the df is 13, just using the n-1. So I'm looking at 13, and I'm going over to the 0.9. 0.9 and 13, I run into 7.042. 7.042 would be my chi-square sub 0. All right. If it's a two-tailed test, it's a little weird. You've got to find two values, and they correspond to the df and half alpha, and then 1 minus half alpha. So first, do half of alpha, or 0.01 divided by 2. That's 0.005. Okay, so, and then the df is 5. So I'm looking at 5 and 0.005 for my first one. 0.005 down to 5. I run into 16.750. There's my first one. And then the other one, it says do 1 minus that. Right? So 1 minus half alpha, or 1 minus the 0.005 is 0.995. So use the DF5 and the 0.995. So I'm going 0.995 and DF5. That gives me the 0.412. So my 0.412 is my other one. Okay. So I did that just by looking at that table. 3 different, left, right, two-tailed tests. And again, you'll have to do some of those, but when you get to the hypothesis test, it's always going to be a right tail, which is the easiest one. You don't do anything fancy. You just look up the alpha and the DF, and then boom. Okay. So there's how we do the table. So let's get back to the packet, and we're going to try this goodness of fit hypothesis test. All right. Here's my chicken scratch writing from what I just did, right? Those are my 3 answers if you want to see it, right? Or check out the notes that I rewrote. It probably looks nicer than this, but we're good there. Okay, moving on. We're going to go to our next page, and we're going to try this goodness of fit hypothesis test. Basically, what's happening here is you have a claim about some sort of distribution. So here's a good example. Here's a claim about a distribution of music preferences. Okay, that's what the radio station is claiming people like. All right, and then we're going to test that claim by doing a sample. Over down here is the sample that's been drawn. So they randomly selected 500 listeners, asked them what kind of music, and there's the distribution. Okay, so the claim is always what we're going to call expected, and from the sample is always what we'll call the observed. We observe it from the sample. Okay, and we're going to now test the radio station's claim that this distribution up here is correct. Okay, so let's go through the steps of how that would look. It's the same 6 steps, right? So first thing you do is state the H sub 0 and H sub A. It's not going to be anything mathematical. It's just statements. I mean, this is kind of always the statements here for every problem. HO is that the frequency distribution is right, fits it. H sub A is that it's not right. It's that it's different than what was expected. Okay. Here's something nice. The goodness of fit test is always right-tailed. You don't have to decide because these are always the same, HOHA, and always right tail. So that's always step 1. That's step 1 for this problem. Step 2, we're always gonna verify that the conditions are met. We have random, and then each expected frequency must be greater than or equal to 5. Okay. We'll get to that in a second when we find those expected frequencies. All right. Okay, so here's where the meat of the problem occurs. We have to calculate that standardized test statistic, and here's how it's done. So you've got, like we specified before, observed frequencies and expected frequencies. The observed are the ones we see from the sample. There they are right there, 8, 2, 10, 72. I'm just going to rewrite them down here. 8, 2, 10, 72, and then what else we got? 10, 75, 125. Okay, 10, 75, 125. Okay, that's what we have observed. The expected is what we would expect to see if that original claim is true. If this is true, and we ask 500 people what their preferences are, what would we expect to see? What would we expect the numbers to see? Now, we would expect to see 4% of those 500 classical. So I have to calculate that down here. So this value, I got to figure out 4% of 500. So I'm going to always multiply the percent times that sample size. Okay, so we're going to do that for each of the categories. So that's 20. Right? And as to not bore you too much, I just went ahead and did them all. There they are. Okay, so we have observed and expected. How do they look? Right? This is what we'd expect to see, the E's, and this is what we actually saw, the O's. They're close. All right. To get that that test statistic, now we're going to apply this formula up here. And it's a little long, but it's doable. Notice what that says to do. It just says, okay, take O minus E and square it, and then divide by E, and then add all of those up. So this would look like, for that first one, 8 minus 20 squared, and then divide by the 20. And then continue the next one down. So I'm going to add the next one. 210 minus 180. Square it, divide that by 180. Continue, and do all these. 72 minus 55 squared, divided by 55. And I run out of room. But we're just going to keep on going. The next one. And then I just fast forward a little bit. There's all of them, right? And you're summing them all up. So take a moment. You want to push pause and check that out and see if you get that 22.7. Put that all into your calculator. I just put it all in at once. Now there is a StatCrunch way. This might be a little long. I'll show you that later. But that's the by hand method. Okay, that's our critical value. That's a chi-square. The chi-square score. Okay. So let's get to step 4. Next, you got two options. You can do a p-value or a critical value. Now, critical value is what we just did using that table. So that's the way we'll focus now because we're doing it by hand. You're going to find a p-value, pretty much just going to do StatCrunch, which we'll get to that later. So let's do on this one a critical value. Okay, so follow the steps on page 1 that we just did, but DF is k minus 1, where k is the number of categories. So here we had 6 categories. So 6 minus 1 is 5. That's our degree of freedom. And this was a 1% level of significance. So I jumped to my table. I'm going to check that out. Remember, always a right-tailed test. So all you're doing is looking up the DF along with the level of significance. There's a 1%, DF5. I'm seeing a 15.086 for my critical value. That would be a chi-squared sub 0. What was it again? 15.086. If I'm going to make a decision, think about what this distribution looks like. You have this chi-square distribution. It's always a right-tailed test, so you have the shaded region to the right. And that 15.806, that critical value, is right on that shaded region. And then you're going to put the standardized test statistic on the graph. 22 is bigger than 15, so it's in the shaded region. Okay, and anytime it's in the rejection region, in that shaded region, you're going to reject H sub 0. So this one would be reject H sub 0. And now for step 6, it's the same as what we've seen, right? There's that same table from chapter 7. Okay, so which of those 4 is it? Well, we rejected H sub 0, so it's one of those, right? Let's reject H sub 0. And then which one was the claim? The claim was H sub 0, right? The claim was the radio station's claim. Right? It said, test the radio station's claim, which was this distribution, which is the H sub 0. The frequency distribution fits that specified distribution. Okay, so H sub 0 was the claim, and we rejected H sub 0. There is sufficient evidence to reject the claim is our final answer on this one. Okay, so that's it for now. I'll stop there, give those a try. We'll do another example in the next video and also fold in some StatCrunch. Okay, hope all is well. Talk to you later.